Good morning to everyone. Last video we have discussed about the purpose of polynomial functions and then order of polynomial functions for an 1D, 2D and 3D objects. And then we have discussed about the applying a material properties for an different material behavior applications. Now in this video we can going to discuss about the derive the element equations for an individual elements. In this, by making use of available laws and principles, we obtain the equations that the governing the behavior of the elements. So already we discussed in the engineering mechanics, the different types of physical laws are available. Based on that physics law, we can apply the laws for engineering and get the solutions. So in this, we are taking as laws from physics and applying for a particular application. So there are different variational energy methods are available. Among them, most common stationary potential energy method. So like that, the variations of energy methods available. Here we are taking it as a potential energy method. The potential energy methods are classified as total potential energy, includes strain energy due to elastic deformations and external work capability by applied force or loads. Here the strain energy means already energy stored in the objects within the elastic deformations, as well as external work capability, how much of work will occur for an applying loads. Combined of this, we will get as a potential energy method. Based on this, we can govern the equations and find the equation of elements. This is the governing equations. The total potential energy equal to strain energy as stored energy plus work of potential, how much of work it will be carried out. So the strain energy is of stress transfer strain dV. In the transfers of stress strain with respect to the dV, we can find as strain energy, or is of k phi square or of k phi, like that we can find the strain energy. And then work done equal to minus uit and pi minus integral of s ui transfer t ds minus ui transfer fd. So based on this, we can find the work force, where ui is in strain energy, sigma is in stress, and E is in strain, PA equal to point load, and then T is in traction force or friction force, and F is in force of the body or self weight. Based on that, we can find the equations. Here, the derivative equations or element equations will be generally classified into n stiffness matrix into displacement vector equal to force, where stiffness matrix K equal to property of the elements. What is the kind of property it can available? So it will be mentioning as a structure of the objects. And then U will be an behaviors, which kind of output it can be produced, like that will be mentioned. And then F will be an action, which kind of inputs you are given to the particular objects. Based on that action, the behavior will be occurs for a particular property. So here there are classified for different applications, the property, behavior and action. For elastic material, structure material, the property will be stiffness, behavior will be displacement, and then action will be force. If we applying the force for a particular stiffness for a particular object, the displacement will be an output. If we go for a thermal, for conductivity is a property, behavior is a temperature, the action will be a heat source. We are applying a heat source based on the conductivity, the temperature will be flow. For fluid, the property will be viscosity, the behavior will be velocity, and then the action will be in body force. If we are applying a force, the velocity will be produced depends upon the viscosity. For electrostatic, dielectric permittation property, electric potential is in behavior, charge is in action. So thank you. We will watch it.